Welcome. So now we're going to figure out if we can determine whether or not these triangles are congruent. You only know two techniques so far, right? So side, angle, side, and side, side, side. So it's either going to be one of those, or we're not going to be able to determine they're congruent at all. It won't be a method we haven't learned yet. All right, so let's take a look. I have a screen covering. I'm going to move my screen. So let's take a look. Is there any information that we could fill in? All right, so let's see. What do we know? Well, we know angle 1 and angle 2 are vertical angles, right? Two angles form, oops, I don't know why that moved. Two angles formed by intersecting lines. Hopefully that won't happen again. There we go. And so we know those have to be congruent to one another. So now let's list the corresponding congruent parts, right? So we're given that MP is congruent to NP. That's a given. Actually, I'll write that down. So this is a given. Right? We determined that angle 1 is congruent to angle 2. Right? That's because those are vertical angles. We were also given that side PL was congruent to side PO. That's a given. And notice our two givens and the angles that we determined were congruent because they're vertical angles gave us side, angle, side. Notice that angle is between the two sides. And if you're not sure, if you just trace the sides to where they intersect, right, that's the included angle. Right? So if that's the angle that's marked, and you've got side, angle, side. If it's any other angle, then it's not side, angle, side. It's side, side, angle. All right, so we can see in both cases, if we follow the sides to where they intersect, right, we've got the angles between those sides. So this would be side, angle, side. So there we go. All right, we've proven the triangle's congruent using side, angle, side, triangle, congruence postulate. All right, let's try some more. And some of them are in your notes. All right, so let's try this one and see if we can figure out if these triangles are congruent. All right, so always you want to list, you don't want to just guess randomly, you want to list your congruent parts. All right, so let's list our congruent parts. All right, so we have, notice that, and we'll do this as a little proof here. All right, so we have our statements and our reasons. All right, so if we look, we've got RQ is equal to 5. And PQ is equal to 4, and angle Q equals 100 degrees. And all of those were given to us. Can I move this over? Yes, I can. All of those were given. We also know that VT is equal to 5, and ST is equal to 4, and angle T is equal to 100 degrees. And that is also given to us. Right? Well, if RQ and VT are both equal to 5, those have to be congruent. So RQ is congruent to VT. And if PQ and ST both equal 4, then PQ has to be congruent to ST. And if angle Q and angle T both equal 100, well then angle Q has to be congruent to angle T. And now I need more space. And the reason that we know these things, oops, oh, that's okay. Angle T there is going to hang on. I guess these two are connected somehow. That's okay. Here, we'll just say, continue on right there. Right? So how do we know those things to be congruent? Well, we know that, oops, there should have been a 2 here. We know that congruent segments and angles have the same measure. So congruent segments and angles have the same measure. Let's see if it matches one of our triangle congruence postulates. So we have 2 sides, right? Let's go to where they meet and the angle between them. So if we look at our sides, right, notice that we have this side congruent to this side congruent to this side. Notice where our angle is. It's right in between those sides. So because that angle is in between these sides, we know for sure that this is a yes. Triangle PQR is congruent to triangle STV using side angle side triangle congruence postulate. And so we were able to figure that one out. Let's try another one. So you're going to find all of your congruent parts between the 2 triangles. Right? Sometimes they're given. Sometimes there's something you'll have to use a property of geometry to figure out. And then you're going to look to see, does it match one of your 5 triangle congruence postulates? There will be 5 before we're done. Right now, it says it match one of the 2 congruence postulates that you know. Right, and let's try the next one. Oh, so here we were supposed to list the congruent parts, but we did that down here in the little proof. All right, let's try this one. All right, is our triangle FGH congruent to XYZ by side angle side? Let's mark our congruent parts. Right, so when you have it, don't just look at it and go, oh, I got some sides and angles. Oh, it must be side angle side. Mark them, all right? So that'll help you see it better. Right? When you see just numbers there, it's hard to really take in where things are located. All right, so we have FG there is congruent to XY. Right, so I'm going to write it down actually. Right? And we won't do, we're just doing this one informally. All right, so it won't be a full proof. So FG is congruent to XY, right? They're both 7. And here we got these 2. HF is congruent to ZX. Right? And then we have an angle measure. Angle H is congruent to angle Z. Oops, that's supposed to be a Z. So, is that side angle side? Let's check. Right? Well, look where that angle is located. Is that angle between the sides? It is not. Right? So, is triangle FGH congruent to triangle XYZ by side angle side? Our answer here is a big old no. Okay. Why? The angle is not the included angle. So our congruent angle is not the included angle. I'm going to move these over a little bit. And boy, is that moving in pieces. I think it goes like that. And oops, the Z didn't move along. There we go. All right, so the congruent angle is not the included angle. Right, and we know that side angle. I hope this is not, I'm not writing too low and that you can't read it. Oops. Oh, that's all connected. I can't do that. So I'll try not to write too low here. So side angle angle is not a triangle congruence postulate. Right? It doesn't guarantee a unique triangle. So that's not one of our triangle congruence postulates. Right? So if you're having trouble figuring out where the included angle will be, I'll show you how to figure it out from your your congruent sides. All right, so F and G, side FG and side HF, what do they have in common? They have the F in common. All right, that means they meet here at F. That's the included angle. All right, so now let's look at X, Y, and ZX. They have X in common. That means they meet here. All right, so that means that this right here is the included angle. So they'll share that letter because that's where they meet, and that's the included angle. So we don't have F and F congruent to X. We don't know. Maybe they are, maybe they're not. Right? We have H and Z, and that would not guarantee a unique triangle. So we cannot prove these triangles congruent. And we're moving along. Waiting for the page to turn. All right, so using side angle side, what information do you need to show triangle ABC congruent to triangle DCB? All right, so it says side angle side. Right? So if it said side, 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 our answer would be one thing. Right? But it says side angle side. So now look to follow your sides. All right, so notice if I follow my sides, this is where the two of them meet. Right there. All right, so that's the included angle. And the same thing over here. Follow the sides. Whoosh. That's the included angle. So the angle that has to be congruent. So notice I can't say B and C because B, this is angle B. Right? So angle B implies that, the whole B there. All right? There's no way for us to know, oh no, I didn't mean the whole B, I just meant that little part of B. Nope, can't do that. You got to name it with 3 letters. All right? So this is, can't do it with using just 1 letter. All right? There's actually 3 angles there that have B as the vertex. So can't use that one. All right, so now let's check the other ones. All right, so we have DBC. No, I want DC, right? C's got to be second. All right, so that's a no. All right, so now so ABD, we'll start with the other angle. So AB, that's the vertex, good. ABD is good. Is DCA right? DCA, oh, I blew it. DCA is, let me use my pen. DCA is this angle here. That's DCA. All right, that big angle over there, that's not going to be congruent to our little green angle, and that's not what we wanted. We want the little blue angle there. All right, so they were almost right, right? But this part was wrong. Right? That part was wrong. Right? So because that part was wrong, this whole thing is wrong. Well, it better be the last choice because we're going to have choices. And notice ABD is also wrong. In my head, I guess I was reading ABC. ABD is wrong. ABD would be this whole thing. Right? This whole thing and this whole thing. Right? So that's what ABD and DCA is, but that's not right. Right? That goes over 2 triangles. That's not the angle we need. That's not the included angle. I may have said ABD, but in my head I was thinking ABC. Good thing I caught that DCA is wrong. So now we do have to hope that this one's right. All right, ABC, all right, that's good. And DCB, that's it. That's the right one. So this is the included angle. And that's the right answer. All right, that's what we would need to be able to show triangle ABC was congruent to triangle DCB using side angle side. Right. Some of these are in your notes, just a few of them. I don't think any of these multiple choice ones. So you, of course, can take extra notes, and I'll remember that. All right, so let's take a look at this one. This might be our last one, right? Because I have other problems picking up on the next podcast, which is already made. All right, so we want to figure out what type of congruence exists between the 2 triangles. Is there anything that we could mark that's not marked? We don't have 2 intersecting lines, so we don't have vertical angles. Right? We have angles that are so we don't have angles that are formed by just 2 intersecting lines. Right? They're formed by 2 lines, just not the same 2 intersecting lines. But there is something else we could mark. what about that right there? Right, so notice this is a shared side. Right, and that shared side is congruent to itself using the reflexive property. Oops, there we go. Reflexive property. Right, so now let's see if we have what we need. Two sides and the angle between. Two sides, the angle between. We've got side, angle, side. Triangle congruence. So be careful, not everything is going to be marked. Sometimes you have to remember that things like shared sides are going to be congruent to themselves using the reflexive property. And do we have another problem, or do we have a blanks page? And we're just waiting for you to turn. Oh, no, we have one more problem. All right, so what type of congruence exists between the two triangles? All right, so no vertical angles here. We don't have any angles that are formed. We don't have any intersecting lines that creating four angles. But if you remember the last problem, we got a shared side. All right, so this is congruent to itself. This is the reflexive property. And we have, look at that, side, angle, side again. Ooh. All right, so if you saw it not congruent, you forgot about the shared side. All right, that's going to be congruent to itself. And do we have another problem or a blank screen? You guess. A blank screen. So that means the next problem is on the next podcast. So come back and watch some more problems and more triangle congruences using side, angle, side. All right, that'll be the focus of the next couple podcasts. All right, bye for now.